morning students. Welcome back to your physics online class. Students, in the last tutorial we have completed the chapter number 2, units and measurement. And now today we will start here the chapter number 3, motion in a straight line. What is the chapter? Motion in a straight line. Students, in class 9th you have studied about the chapter motion, in which you have learned about different types of motion, different terms related to the motion like velocity, average velocity, acceleration, retardation, graphical representation of different types of motion. So all those things which you have learned in class 9th, those things are base of this chapter now. So first we have to remind all the things. You have to revise all the things which you have learned in class 9th. The chapter motion, it was there. So let's start. First of all, we have to understand what do you mean by motion in a straight line. So to understand this motion in straight line, you have to categorize the motion in 3 parts first. Motion is now categorized in 3 categories. One-dimensional motion, or also known as motion in straight line. Motion in straight line. Okay. Second, two-dimensional motion. That is motion in the plane. It means motion in a plane. And the third one is, last one is three-dimensional motion. That means motion in space. Motion in space. Let's see first these 3 categories. First of all, let's see what is motion. So you all know that when a body changes its place with respect to time, then the body is said to be in motion. Repeating, when a body changes its place with respect to time, and also you can say that with respect to a observable point. Observatory, you can say, with respect to a reference point. You also use this term, reference point. When a body changes its place with respect to a reference point, and obviously with respect to time, then the body is said to be in motion. For example, moving train, moving planets, moving a person, running athlete. So different examples are there in surrounding in our surrounding. Different things are there which are in motion. So this is the motion. Now there are 3 categories: one-dimensional motion, two-dimensional motion, and three-dimensional motion. So first of all, suppose your object, a body, has its initial position with coordinate x, y, z. This, suppose P is the point, initial position of the object, which has its coordinate x, y, z. X, y, z means it is in space. The body is in space. Class 10 तक पढ़ा हुआ है x, y only. X, y means the position of the point is in xy plane. But this is x, y, z. All the 3 coordinates used here. It means the point या object is at a point or object is in space. Okay. Now see, if with respect to time, when time changes and the body's position the body's position changes with new coordinate like x1 y z or x y1 z. This is comma, this is x1 y z, and this is x comma y1 comma z, or x comma y comma z1. See the three possible situation in one dimensional motion: x1 yz or x y1 z or x y z1. Again, this is comma. So if initial position is x comma y comma z, and the new position means after time t, its position is given by x1 yz or x y1 z or x y z1, then the body is said to be in one dimensional motion. Body is said to be in one dimensional motion or motion in straight line. Okay? It means that out of the three coordinates, if any one coordinate changes with time, then the body's motion is called one dimensional motion. Clear? Out of three coordinates, any one coordinate, ya x, ya y, ya z. In first example, x changes to x1, in second one, y changes to y1, and the third, z changes to z1. तो इस तरह देखा गया है कि any one coordinate changes here only with respect to time, then the motion is said to be in one dimension. क्या उसे बोल सकते हो? Motion in straight line. For example, the train moving on the railway lines, ठीक है, or a person moving on the straight path. So this type of examples, with this given coordinates, the body's motion will be in one dimension. Now see the second one, two-dimensional motion, या बोलेंगे उसको motion in plane, motion in a plane. For body's motion in the plane, any two coordinates will change with respect to time, like initial x y z, x comma y comma z, and the new position या final position will be x1 y1 z or x1 y z1 or x y1 z1, such type of examples in which any two coordinate changes at a time. अगर time के साथ साथ out of three coordinates any two coordinate changes, देखो in the first example x and y changes, in the second one x and z changes, and third y and z coordinate changes with respect to time. So this example shows that this new position of the body shows that the body is in two-dimensional motion, या कह दो body is moving in a plane. For this example, body is moving in xy plane. For this example, body is moving in, this is comma, body is moving in xz plane, and in the third one the body's motion is in yz plane. ठीक है, तो this is the motion in the plane. Now in third, three-dimensional motion, all the three coordinates will change with respect to time. Means initial position x y z, then the new position becomes x1 y1 z1. Okay, means all the three coordinates changes here with respect to time. देखो initial position p and new position is q. So all the three coordinate changes. So this is the motion in three dimension या कह सकते हो मोशन इन स्पेस। मोशन इन स्पेस को एग्जांपल कह सकते हो, मोशन इन स्पेस मीन्स फ्लाइंग काइट और फ्लाइंग एरोप्लेन या मूविंग एयर मॉलिक्यूल्स इन स्पेस। These examples are of three-dimensional motion या motion in space. Okay. So this is about the three category of motion: one-dimensional, two-dimensional, and three-dimensional. In class 9th, we have categorized this motion in two categories. We have studied two types of motion: uniform motion and non-uniform motion. This is the category we have studied in class 9th: uniform motion and non-uniform motion. So let's see the difference between uniform motion and non-uniform motion. Let's remind all the things which you have studied in class 9th. So let's define first what is uniform motion. Uniform motion means constant speed or constant velocity. Now we have two new terms, speed and velocity. You know the difference between speed and velocity? So constant speed means if the body's speed is constant throughout the motion, it means the body covers equal distances in equal interval of time, and the body's motion is called uniform speed. Yeah, body is said to be in uniform speed, या उसको बोल सकते हैं uniform motion भी बोल सकते हैं. And also we have studied about the velocity. If the body shows equal displacements in equal interval of time, then its motion is said to be uniform velocity. Or combinedly both are called uniform motion. Finally, uniform motion का मतलब हो गया body shows equal displacements या equal distance in equal interval of time. In first 5 seconds, if it travels 50 meter, then in the next 5 seconds also it shows the 50 meter displacement or distance. Displacement and distance ये भी category हमारी बनी थी, difference बनाया था class 9th में. Distance is the, what is distance? Let's see here. सभी remind कर लो. Distance and displacement. Distance means the length of the traveled path by the body. Distance means the length of the traveled path by the body is called distance. Unit, you know, almost SI unit is, yeah, MKS unit is meter, and other units, different units are there: centimeter, kilometer. And in last chapter we have studied the different astronomical distances, units also for distance. So many units are there, but we will use meter for a meter in SI system or MKS system. And what is displacement? Displacement is the shortest distance between initial and final position of the body. Shortest distance between initial and final position of the body is called displacement. This is vector quantity, this is scalar quantity. सब पढ़ा हुआ क्लास 9th में. स्पीड को पूछे व्हाट इज स्पीड, तो कह देंगे स्पीड मीन्स रेट ऑफ चेंज ऑफ पोजीशन, या कह दो द रेशियो ऑफ डिस्टेंस टू द टाइम टेकन. डिस्टेंस अपॉन टाइम, दिस इज स्पीड. SI यूनिट मीटर पर सेकेंड. वेलोसिटी, व्हाट इज वेलोसिटी, तो कह देंगे इट इज ऑल्सो द रेशियो ऑफ डिस्टेंस एंड टाइम, बट डिस्टेंस ट्रेवल्ड शुड बी along the straight path. या कह सकते हो वेलोसिटी इक्वल्स टू डिस्प्लेसमेंट अपॉन टाइम. Velocity is a vector quantity, speed is a scalar quantity. Okay. So this is about the uniform motion. मैंने बता दिया uniform motion means constant speed or constant velocity. And you know that speed and velocity both will be same. Speed and velocity both will be same when the body moves on, when the body travels on the straight path. For a straight line motion, speed, distance and displacement both will be same, and also speed and velocity both will be same. ठीक है, ये सब क्लास 9 में पढ़ा रखा हुआ है. So this is about the uniform motion. Non-uniform motion. So non-uniform motion means when the body travels unequal distances in equal interval of time. It means with varying velocity. If the velocity of the body varies with respect to time, it is not constant throughout the motion, then the motion is called non-uniform motion. In non-uniform motion means velocity should be vary. Velocity vary means velocity should be changes, and change का मतलब हो गया it may increase also, it may decrease also. If the velocity increases with time, then it is called acceleration. When the velocity of the body increases with time, या कह दो if the rate of change of velocity is positive, then it is called the acceleration. And if the rate of change of velocity is negative, so this is called the retardation. Rate of change of velocity positive, तो उसे कहेंगे acceleration. Rate of change of velocity is negative, then this is called the retardation. Okay, so this is about the non-uniform motion. इसके बाद भी कैटेगरी बनाई जाती है. एक्सेलरेशन में भी बनाई गई यूनिफॉर्म एक्सेलरेशन एंड नॉन फॉर्म एक्सेलरेशन. इसका ये मतलब हुआ कि यूनिफॉर्म का मतलब याद रखो, यूनिफॉर्म मीन्स कांस्टेंट. तो इफ द एक्सेलरेशन रिमेन्स कांस्टेंट थ्रू आउट द मोशन, इसका मतलब रेट ऑफ चेंज ऑफ वेलोसिटी इज कांस्टेंट थ्रू आउट द मोशन, देन द मोशन इज कॉल्ड यूनिफॉर्मली एक्सेलरेटेड मोशन. और अगर बॉडी का मोशन जो है, बॉडी के मोशन में इट्स रेट ऑफ चेंज ऑफ वेलोसिटी इज नॉट कांस्टेंट, रेट ऑफ चेंज ऑफ वेलोसिटी इज नॉट कांस्टेंट, कभी तेजी से वेलोसिटी बढ़ी कभी स्लोली, तो ऐसे मोशन को बोलेंगे नॉन यूनिफॉर्मली एक्सेलरेटेड मोशन. तो दीज आर द कैटेगरी और डिफरेंट टाइप्स ऑफ मोशन वी हैव स्टडीड इन क्लास 9. ठीक है. एंड ऑल्सो वी हैव लर्न about the graphical representation of different types of motion. So I suggest you should go through the syllabus or the chapter number 9 especially of class 9. Class 9 के chapter number 9 or 11 it is, but chapter number 9 or 11 whatever be the number, but the chapter name is motion. So you should go through the chapter motion of the class 9th and revise all the things. I am repeating, all the things are base for this chapter. So अगर आप भूल गए हुए हैं तो you should go through the chapter motion of class 9th. Okay. Now see here. Our next topic, you can say our first topic of this chapter is average velocity. Average velocity. See here. Suppose the body starts from O. Body starts its motion from this point O, and at point A its position is x1. After time delta t interval of time, body reaches new point B with new position x2. x1 x2 means OA equals to x1, मतलब समझो OA equals to x1 यूनिट मीटर और सेंटीमीटर एंड OB equals to x2, ये मतलब है. ओके, पोजीशन मीन्स OA x1 OB x2 when O is the reference point, मतलब यहाँ से ऑब्जर्वेशन ली जा रही है. And this is the time interval in which the body changes its place from x1 to x2. अब चेक किया गया एवरेज वेलोसिटी represented by V bar. Now we will represent the average velocity by this sign symbol V bar, and it is equals to x2 minus x1 upon delta t. Delta t का मतलब at this point time is t1, at this point time is t2. So you can also represent here t2 minus t1, and that will be delta t. And this distance, yeah, displacement will be delta x. And time interval is delta t. Time कितना लगा delta t? इस delta t time interval में what is the change in position? Delta x. So now we can represent this average velocity V bar equals to delta x upon delta t. So this is the average velocity. This is the average velocity for the time interval delta t. ये याद रखना, ये है एवरेज वेलोसिटी का मतलब. क्लास 9 में जो पढ़ते थे एवरेज वेलोसिटी, उसे बोलते थे इजीली कि एवरेज वेलोसिटी का मतलब है टोटल डिस्टेंस अपॉन टोटल टाइम इंटरवल, या टोटल डिस्प्लेसमेंट अपॉन टोटल टाइम इंटरवल. इसे ही बोलते थे वहाँ पे एवरेज वेलोसिटी. बट नाउ सी हियर व्हाट इज द एक्चुअल मीनिंग ऑफ एवरेज वेलोसिटी. एवरेज वेलोसिटी मीन्स change in the position of the body with respect to the given time interval delta t. एक delta t time interval में what is the change of the body, what is the change in position of the body. So this is called the average velocity. Okay, अच्छा अभी डायग्राम रहने दो भाई जो बनाया था अभी. This was B, this is B, T2, ये this is A, X1, X2, and this was O. ऐसे. तो this is about the average velocity. Now what is velocity? अब velocity की बात आई तो actual velocity means, velocity जब बात कर रहे होते हैं, velocity का मतलब हुआ we are going to find the velocity at a particular point. Particular point means, देखो, this V bar is not the velocity at a particular point. It is not the instant velocity. ध्यान देना, ये जो average velocity आई हुई है, this average velocity is for this time interval delta t. इन दोनों पॉइंट के बीच की ये velocity है average velocity. और next topic is, see here, instantaneous velocity. Instantaneous velocity means velocity of the body at a particular point. Means यहाँ पे velocity क्या है, या यहाँ पे velocity क्या है, या particular point या particular position पे what is the velocity of the body, that is called the instantaneous velocity. या in short बोलते हैं instant velocity. Okay. So let's see the difference between average velocity and instantaneous velocity. अब बात समझ में आ रही है with diagram. This average velocity is the velocity for the time interval delta t. It is not for the particular point. It is not for the particular time. This is for time interval delta t. And instant velocity and instantaneous velocity means velocity of the body at a particular point. Particular point means at a particular time. बोलेगा instant velocity means at a moment. जब बॉडी यहाँ पहुँची तो व्हाट इज इट्स वेलोसिटी, नॉट फॉर द टाइम इंटरवल डेल्टा टी, जस्ट फॉर अ पॉइंट, जस्ट फॉर इंस्टेंट ऑफ टाइम व्हाट इज इट्स वेलोसिटी. दिस इज कॉल्ड द इंस्टेंटेनियस वेलोसिटी. सो लेट्स सी व्हाट इज instantaneous velocity. Instantaneous velocity is defined as, पहले बता दो क्या है instantaneous velocity. तो कहते हैं instantaneous velocity means velocity of the body at a particular point or at an instant of time t. At instant of time t, and it is defined as, मतलब instantaneous velocity v is defined as the limiting value. पहले देखो लिख देते हैं limit delta t tends to 0 delta x upon delta t से here. Now this is the instantaneous velocity. क्या है v की definition देखो. Instantaneous velocity is defined as the limiting value of average velocity. ये क्या है average velocity कितने टाइम इंटरवल के लिए, डेल्टा टी टाइम इंटरवल के लिए. एंड दिस लिमिट, दिस इज द लिमिट. इन मैथमेटिक्स यू विल स्टडी अबाउट द लिमिट प्रॉपरली. So just see here what is the meaning of instantaneous velocity. Instantaneous velocity is defined as the limiting value of average velocity for this time interval approaches zero. Approaches zero means कह सकते हो tends to zero. फिर से पढ़ रहे हैं, ध्यान सुनो, नई चीज़ तुम्हारे लिए है. टाइम दो इस पे. Instantaneous velocity is defined as the limiting value of average velocity. Limiting value of average velocity for the time interval delta t, where this time interval approaches zero. Approaches zero means this is going to the value zero. Means this interval decreases and goes towards the zero. जैसे देखो this time interval delta t. अब ये टाइम इंटरवल अगर कम करते चले जाओगे, देखो ध्यान दो, मेरे हाथ को ध्यान दो. अगर ये टाइम इंटरवल कम होती चली गई, मतलब अब पॉइंट ए और बी यहाँ आ गई और क्लोज हो गई और क्लोज हो गई, तो जो ए और बी पॉइंट्स क्लोज होती जाएंगी तो टाइम इंटरवल डेल्टा टी गोज टुवर्ड्स जीरो. तो इसी को बताया गया है when delta t tends to zero, the limiting value of average velocity is called instantaneous velocity for the instant of time t surrounded by t1 and t2. Surrounded by t1 and t2 का मतलब क्या हुआ, जिस इंस्टेंट ऑफ टाइम t पर आप इंस्टेंटेनियस वेलोसिटी निकाल रहे होंगे वो टाइम t किसके बीच में होना चाहिए, इस t1 एंड t2 के बीच में ही होना चाहिए. नॉट बिफोर a एंड नॉट आफ्टर b. समझ में? जैसे आप जिस इंस्टेंट ऑफ टाइम पे, जैसे मान लो ये देखो दो क्लोजर बी दिख रहे हैं, देखो फिर से. नाउ टू क्लोजर पॉइंट्स ए एंड बी and the time t at which we are going to find the instantaneous velocity, it should lie between these 2 points. These two means t1 और t2. जो टाइम इंटरवल लिया गया t2 minus t1. What do you mean by delta t? Delta t means t2 minus t1. तो जो डिफरेंस लिया गया t2 minus t1, the instant t जो जिस टाइम पे निकालना चाहते हैं instantaneous velocity, it should lie between t1 and t2. ठीक है, जिसे नहीं समझ में आया फिर से सुन लो. व्हाट इज इंस्टेंटेनियस वेलोसिटी, दिस इज न्यू थिंग फॉर यू, सो पेशेंस बनाए रखो एंड लिसन प्रॉपरली. सो इंस्टेंटेनियस वेलोसिटी इज डिफाइंड एज द लिमिटिंग वैल्यू ऑफ एवरेज वेलोसिटी फॉर द टाइम इंटरवल डेल्टा टी, वेयर दिस टाइम इंटरवल डेल्टा टी अप्रोचेस जीरो, या बोलते हो टेंड्स टू जीरो, एंड the instant time t should lie between t1 and t2 only. जिस instant of time पे निकालना चाहते हो, it should surrounded by the time interval delta t. This is about the instantaneous velocity. और क्लियर करते हैं, देखो this is t1, this is t2 with point a and b, position x1 x2. अब बताया कि फॉर दिस टाइम इंटरवल डेल्टा टी, फॉर दिस टाइम इंटरवल डेल्टा टी द वेलोसिटी इज कॉल्ड एवरेज वेलोसिटी. वेलोसिटी इज कॉल्ड एवरेज वेलोसिटी. v बार इक्वल्स टू डेल्टा x अपॉन डेल्टा टी. अब कहता है कि व्हेन when this delta t tends to 0 means approaches 0 means now we have to bring these 2 points A and B closer and closer. अब सोचो कि ये जो A और B पॉइंट काफ़ी क्लोज आ गए और क्लोज इतना क्लोज हो जाए कि ये जो टाइम इंटरवल इन दोनों के बीच का हो it should be nearly zero, not equals to zero, nearly zero. जब ये टाइम इंटरवल लगभग जीरो के क्लोज हो जाए, बहुत क्लोज हो जाए, so at that moment, at that point the velocity will be instantaneous velocity. इन दोनों पॉइंट के बीच में एवरेज वेलोसिटी. अब ये पॉइंट काफ़ी क्लोज हो गए, इतना क्लोज हो गए कि डेल्टा टी टेंस टू 0. सो इन दोनों क्लोजर पॉइंट्स के बीच में जब वेलोसिटी, इन दोनों के बीच के गैप में जब वेलोसिटी निकाली जाएगी, वेरी क्लोज, यहाँ तो मैंने काफ़ी गैप दिखाया है, ये काफ़ी क्लोज हो गए हैं 2 पॉइंट्स, तो उन क्लोजर पॉइंट्स के बीच में जब एवरेज वेलोसिटी निकालोगे तो दैट विल बी इंस्टेंटेनियस वेलोसिटी. Clear? Now see how to represent the instantaneous velocity. So this is the way. V equals to limit delta t tends to 0, delta x by delta t is the instantaneous velocity. And now we will use this symbol dx by dt for instantaneous velocity. Or this is equals to limit delta t tends to 0, delta t tends to 0, delta x by delta t. Dx by dt here. Actually, this is the rate of change of position with respect to time. Here the new thing, dx by dt is the new thing for you. But actually, this is not dx by dt. इसे पढ़ना कैसे चाहिए? कहते हैं d dt of x. d dt of x क्या बोलेंगे? डिफरेंशिएशन ऑफ x विद रिस्पेक्ट टू t. क्या उसको बोलते हैं? डिफरेंशिएशन ऑफ x विद रिस्पेक्ट टू t टाइम. So this is the differentiation of x with respect to time, and it is equals to the instantaneous velocity. Okay. So this dx by dt, या फिर मैं बोल रहा हूँ this is not the ratio, this is not the fraction of dx and dt, it is the rate of change of x with respect to t, या उसको पढ़ते हैं क्या? Differentiation of x with respect to t. So this is the differentiation. So we have to see here what is the differentiation. Check कर लेते हैं differentiation क्या है. Actually we have to use some mathematical tools in this chapter. Basically calculus में mathematics branch is there. Calculus in which we have two branch, differentiation and integration, या कह सकते हो differential calculus and integral calculus. So both will be applied here with their general formulas. कुछ जनरल फॉर्मूले होंगे, सिंपल फॉर्मूले हैं जो आपको यहाँ पे अप्लाई करने होंगे इन दिस चैप्टर. नॉट फॉर दिस चैप्टर ओनली, थ्रूआउट द फिजिक्स, थ्रूआउट द सिलेबस वी विल यूज द कैलकुलस मेथड. सो लेट्स सी द मीनिंग ऑफ डिफरेंशिएशन ऑफ अ फंक्शन. सपोज वी हैव अ फंक्शन ऑफ x represented by y. Y is the function of x. When we changes this value of x in the function, you will get the change in y also. Suppose there is a change in x, delta x. We have used this symbol earlier also. This is the small delta. So this is the symbol used for showing the change, the small change. So delta x is the small change in x in this function. It shows the change in the value of y also. Suppose the change is delta y. X में change किया, small change delta x. Now change in y is small, that is delta y. And suppose these two are delta x and delta y are increasement in the वैल्यू ऑफ x एंड y रिस्पेक्टिवली। मतलब x में बढ़ाया गया डेल्टा x, तो मान लिया y में भी बढ़ गई है वैल्यू डेल्टा y। सो वी कैन रिप्रेजेंट इट एज, कैसे पढ़ेंगे उसे, क्या देंगे, डेल्टा y इक्वल्स टू एफ एक्स प्लस डेल्टा एक्स माइनस एफ एक्स। ठीक है, डेल्टा y इक्वल्स टू एफ एक्स प्लस डेल्टा एक्स माइनस एफ एक्स, और let's divide by delta x on both sides, so delta y by delta x equals to f x plus delta x minus f x divided by delta x. So this ratio shows, this fraction shows what is the change in y with respect to x. When we have the change in value of x, then it will also change the value of y. So this ratio shows the change in value of y with respect to x. Now see, taking limits on both sides, limit delta x tends to 0. These are mathematical tools which we are using here to explaining about the differentiation meaning. differentiation है क्या, वो बताना चाह रहा है तुम्हें। लिमिट डेल्टा एक्स टेंड्स टू 0, तो ये बन गया डेल्टा, दिस इज डेल्टा वाई बाई डेल्टा एक्स, एंड लिमिट डेल्टा एक्स टेंड्स टू 0, एंड दिस इज एफ एक्स प्लस डेल्टा एक्स माइनस एफ एक्स डिवाइडेड बाई डेल्टा एक्स। And now this left hand side is called differentiation of y with respect to x. Okay, this left hand side is represented by d dx of y, या उसको बोलेंगे differentiation of y with respect to x. What is the change in y when we have small change in the value of x? So this is the actual meaning of differentiation. चैप्टर मुझे इस फॉर्मूले को कंप्लीट इस तरह से एक्सप्रेस नहीं करना है, जस्ट वी हैव टू यूज द जनरल फॉर्मूला फॉर द डिफरेंशिएशन. सो नोट डाउन द जनरल फॉर्मूला which will be used in this chapter for differentiation. d dx of x to the power n equals to n x to the power n minus 1. General formula, basic formula of differentiation. d dx of x to the power n equals to n x to the power n minus 1. Example, so we are differentiating here x to the power n, किसके टर्म में, किसके रिस्पेक्ट में, x के टर्म में. So this is the answer, differentiation. Example check कर लो. Differentiation of suppose x to the power 5. So compare these two left hand side. N means 5 here now. So answer will be 5x to the power 5 minus 1, that is 5x power 4. So x to the power 5 differentiation with respect to x is equal to 5x to the power 4. So this is the general formula of differentiation. And I am suggesting you again to revise all the things which you have learned in class 9th of the chapter motion. So this is sufficient for today's class, and tomorrow we'll see, means in the next tutorial we'll see some more formula of this differentiation, and we will proceed to chapter number 3. So for watching this video, thank you very much and God bless you. Keep learning, keep studying. Thank you very much.